Monday morning to all you guys. Just wanted to reach out and do a video for you guys this morning and not really worry about having the Google Meets considering today is a teacher work day. However, before we get started on today's lesson, I did have a few emails from you guys over the weekend about simplifying nth root IXLs. And so what I did is I grabbed a couple of those questions over from IXL just to kind of help you. And yes, I am sipping on my coffee. I think it's important when you're doing these problems to really pay attention to, what they're telling you that what n is. Because in these problems, n dictates whether or not you're going to have to use the absolute value symbol. So whenever you have n to be even, okay, I can't stress this to you enough. Number one, the only time you're going to be using absolute value is if n is even. So if your index is even, you are going to have to use that absolute value symbol only if the exponent expression inside the radical has an odd degree. So if your exponent expression is even. Like, for example, if inside the radical, just use the square root. If I have x to the 6th power, okay, I want you guys to see that x to the 6th, that's even. So my exponent is even. I have an even index, and when I take the square root of that value, it's going to come out, and it's going to be odd. So let me show you how sometimes it's even, and sometimes it's odd. I'll throw in here y to the 8th power. So both of these are divisible by our index 2. So when they come outside the radical, I would have x to the 3rd, and of course, you do the plus or minus, and then y to the 4th. Now, what I want you to pay attention to is this. Both of these exponents are even when they're inside the radical. When they come outside the radical, the 3 is odd. It's an odd number. 4 is an even number. Now, the reason why that's important is because if x happened to be a negative value, that would make that a negative number. So inside here, it'd be negative. And so we have to ensure that it retains positive, because x to the 6th is always positive no matter what. So that means x to the 3rd also must remain positive. And that's why I put the absolute value. And the only time it needs to be that way is when it comes outside and it's an odd number, x to the 3rd power. Y to the 4th, it's always going to stay positive, because anything raised to a 4th power is going to be positive. So that's why I put the absolute value marks around the x to the 3rd power, if you will. Now, so when I do this particular problem, I realize that I'm not going to need the n is said to be even, but, and you're like, Mr. Masson, how do I do this? I think the easiest way to do this problem is to think about it like this. That's x to the 6th n divided by n. Put it back in its rational form. The n's will cancel out because n will go into n evenly, and I'm left with x to the 6th power. Now, I don't need the absolute value because 6, again, is an even value. If it came out as a 5 or as a 3 or as a 1, I would need to put the absolute value around it, but because it came out as x to the 6th, I'm good. So the nth root of x to the 6th n is just x to the 6th power. Right? That was kind of one of the easier questions in that subset. Let's take a look at a more difficult one. So in this particular problem, we're told that n is an odd positive integer. Now, since n is an odd positive integer, no absolute value is needed. And the reason why is because negatives are allowed with odd indexes. So since negative is allowed with an odd index, I don't have to worry about, whether or not it comes out as a negative number. Now, we can take a look at this problem, change it to even in a minute if we need to, but I think it's sufficient with the last example. And let's see what I need to do here. In this problem, I'm really going to need to use the rules of exponents. So I have the nth root of. The reason why I want to need to do this is because 3n plus 1 is not divisible by n. So I'm going to break that thing apart to be x to the 3n times x. And remember, that is x to the 1st power. Right? And that's where I get the 3n plus 1, is because when you multiply like bases, you add their exponents. So x to the 3n plus 1 can be rewritten as x to the 3n times x, right, times y to the 6n. And so we're only going to take the nth root of what is divisible by n. This is divisible by n. This guy right here, let me highlight that. This guy's divisible by n. This guy's divisible by n, the exponent. The x to the first power, it gets to stay inside the radical. Right, so 3n divided by n is just x to the third power. 6n divided by n is y to the 6th power. And then left inside is x, square root of x, or the nth root of x. And again, I don't have to worry about any of the absolute value markings because n is said to be odd. And we've been even, listen to me, have this thing said n is even. So, just in my mind, imagine that it's, I'll just show, how about let's do this? Let's write that. N is even. So if n is even, I want you to see what happens. The answer is the same, except for one thing. That x to the third, it needs an absolute value because it came outside as an odd exponent. In other words, when I say odd exponent, I mean the number itself, 3, it's an odd number. Y to the 6, nth root of x. So the answer is the same, but I need the absolute value there to ensure that it stays a positive value. Alright, just a couple of questions. I did notice those coming up, so I wanted to bring those up. It's a little bit more difficult of a question, but I think once you've seen a couple of examples, you can see that they're fairly simple. Now, let me say this, because I know a lot of you should be watching this video. Many of you haven't yet to log into iExcel. You got an assignment that's due. You're going to have a difficult time getting all those done. Please make sure you're logging in and get those taken care of. Now, today, it's a short lesson. That's part of the reason I'm just going to do a video and give you guys a day off from hearing from me. Solving radical / rational equations. I'm going to do a few of them by hand, and we'll also implore the use of Desmos. Desmos is my favorite. We all know how much Mr. Maston loves Desmos. So without further ado, we'll take a look at that in just a second. But when examining these, we have to remember that we cannot take the nth root of a negative value when n is even / even index. So it's important to check your answers to make sure that they are not extraneous. So let's take a look at the following example. And again, we're going to look at doing it by hand first, and then we'll take a look at Desmos. So let's just jump right in. Example 1. Solving equations, there's really not a lot of directions that are involved there. We just solve for the variable. So let's just solve the following. And that's going to be kind of my directions for all of them. Solve the following. Okay. We have 3 plus the square root of 2x minus 3 equals 8. Now, there's a couple ways that you can do this question. You can do the problem simply looking at radicals, or you can do the problem looking at rational expressions. And I think what I'll do is I'll show you both. So let me do this. Let's group this thing together real fast. And I'm going to slide it over. Do it down here. And I'm going to clone it. I'm going to clone it so you can see how I would do it both ways. There it is. Maybe I haven't had enough copies. So, again, we're going to take a look at this using radicals first, and then we'll take a look at it looking at rationals. So, extraneous solutions. And the reason I'm looking for extraneous solutions, if I substitute a value for x and I get a negative inside here, that's not my answer. So, and then that gets back into talking about the domain. Remember, you can't have a negative value when you're even indexes. So you gotta be careful with your answers. Alright, so let's solve this thing with radicals, and then we'll do it with rational exponents. Same general procedure, but there is a time and a place. Sometimes it's better to use rationals, sometimes it's better to use radicals. In this particular problem, I think radicals is sufficient, but I want to show you both ways for future reference. So I'd subtract 3 from both sides. And if you're over there like, I'm going to do this thing in Desmos, you probably already got the answer. Okay, I got the square root of 2x minus 3. It's 5. we're going to square both sides. And we're squaring the square root, which gets rid of it. What we do to one side, we have to do the other. Common rule that you were taught in middle school. So I'm left with 2x minus 3 equals 25. And now we just have a basic linear equation. We're going to add 3 to both sides. 2x is equal to 28. And then we have x equals 14. Now, again, we need to check to see if it's extraneous. So we'll just march our little cells back up here, substitute 14 in. So just kind of listen as I go through this. 2 times 14, 28. 28 minus 3 is 25. Square root of 25 is 5. 3 plus 5 is 8, which is equal to 8. So I'll check myself. I'm good to go. So, how would I solve this with rationals? Well, to solve it with rationals, we're kind of going to do the same thing. It's all about, when you're doing these problems, I used to tell people all the time, the key to these problems is to get the radical by itself. So I'm going to get the radical by itself, just like I would before. Get the radical by itself, like I did over here. So the first step is equivalent. I subtract 3 from both sides. So I'm left with the square root of 2x minus 3 is equal to 5. Now, I'm going to change this to a rational exponent. 2x minus 3, that's raised to the 1/2 power. So I want to get rid of that 1/2 power. That's ugly. It's nasty. So to do that, I'm going to multiply or raise both sides to the reciprocal of that. The reciprocal of that, and when you do this, you multiply exponents together. 2 times 1 is 2, 1 times 2 is 2, 2 over 2 is 1. So that makes that 2x minus 3. So I'll raise that to the 2 over 1 power. It's the same thing we did over here, except that the perspective is of multiplying by reciprocals to get an exponent of 1 for what is underneath the radical. And at this point, it is the exact same problem as we had over here. And you just solve it as you go through. The only time I'd say that this is easier to work with is for questions that are a little bit more difficult. Now, without further ado, I do want to show you how to do this on Desmos. Alright, in Desmos, so we got our thing right here. We have 3 plus. Now, the thing that I'm going to tell you to do this with Desmos is you're going to take one side, and now I don't know if you've ever been showed how to do this in the 83 or 84, but I'm going to take one side and I'm going to set it equal to y. So I'll go y is equal to that first part, which is 3 plus the square root of 2x minus 3. So that's going to be my first equation. And then my second equation is y equals 8. Right, and again, this is my Desmos procedure. That's what I'm going to do in Desmos. I'm going to type those two in. And what I'm looking for is I'm looking for the intersection to those two. Now let me tell you an awesome thing about Desmos. This is what's great about Desmos. It just won't be explained. Like the y value. The y value we know is going to be the same. That's why they're both y equals. Alright? Let me tell you a great thing about Desmos before I type it in. Desmos does not give you the extraneous solutions. It only gives you the answers that work. So if you're worried about extraneous solutions, Desmos completely gives us the ability to bypass that. So again, Desmos, 3 plus square root, let's find my square root, it's right over here, square root of 2x minus 3, and then we'll set that equal to y. And right here, we got y equals 8. Just master, I don't see it, but y equals 8 is up here, so I have to grab a hold of that screen and slide it over till I find the intersection. And looky right there, look, x equals 14. Is that not what I got? X equals 14. Fast, easy, efficient. Now, what I'm going to do is show you another problem real quick. Again, by hand first. I know you're all like, oh, Desmos, I'm going to do it. I'll get done with my assignment really quick with Desmos. And you're right, you will. And you guys know I'm all about efficiency, but I think it's extremely important that you actually know how to do these problems by hand. So check this guy. 3 times x plus 1 raised to the 2/3 power. I can't stress this to you enough. That raised to the 2/3 power equals 12. That is a radical. Okay, that's a radical. It's a cube root, matter of fact. It's the cube root of x plus 1. But it's given to us in rational form, so we're going to roll with it. So, the first step, what do I do first? Well, we're going to get the rational exponent by itself, which means that 3 needs to go away. So I'm going to divide everything by 3. So I have x plus 1 raised to the 2/3. And I know there's a few of you right now that have already typed it. I know you just already typed it in Desmos. You're already got the answers. You know that there's 2 of them. But I think it's important you understand why there's 2 of them. So watch this. To do this problem, I'm going to raise this to the 3/2 and this to the 3/2. Again, those are reciprocals of each other. They'll give you an exponent of 1. The 2's cancel out, the 3's cancel out. You got x plus 1. However, please pay attention to this. That 2 right there, that means I have an even index radical. That's actually, if you think about that for a minute, that is the square root of 4 cubed. And if I take the square root of 4, I got to drop a plus or minus right there. It's plus or minus square root of 4. So right now, I'm looking at plus or minus. I've got 2 answers that pop up from this, plus or minus. So let's think about it. Square root of 4 is 2. 2 cubed is 8. And square root of 4 is 2. And then 2 times 2 times 2 is 8. That's what 4 to the 3 halves is. You could type that into Desmos if you wanted, but that's what you would get. Now, for this, just like when we were dealing with radicals, I see that I have 2 answers. So I'll subtract 1 from both sides. X equals -1 plus or minus 8. So let's get our 2 answers. -1 plus 8 is 7. -1 minus 8 is -9. My 2 values are 7 and -9. There's my win. Alright, so check for extraneous solutions. Yes, we have to do that still. Now, here's the thing I have to worry about, or I have to think about for a minute. Technically, this is a cube root. So all values are allowed, but I got to make sure they equal to 12. So we substitute. 7 plus 1 is 8. Cube root of 8 is 2. 2 squared is 4. 3 times 4 is 12. It works. -9. Substitute in. -9 plus 1 is -8. The cube root of -8 is -2. But then I do -2 squared, which is +4. 3 times 4 is 12. They both work. But I would be at a loss if I didn't say, let's check this thing in Desmos. So again, when I do this in Desmos, I'm not going to do any solving. I'm just going to start off with y equals 3. Put my parentheses down, x plus 1. Close my parentheses. I'm going to raise that to a 2/3 power. Looks kind of funny when you raise it to a 2/3 power. But right here, y equals the other side, but y equals 12. So now I'm going to hit that home button right there on Desmos. I want you to see what that first graph looks like. It's like a really cool looking V, kind of like the calligraphy V. So I'm going to scroll down until I see 12. Oh, and then when you do that, you see that you have 2 answers. Let's check them out. There's the -9. There's the +7. Desmos gives me both of my answers that fast. So you always need to pay attention to whether or not you've got those 2 answers. Again, Desmos will not give you extraneous solutions. So let's just drop one more on you real fast to make sure we're good to go. Number 3. We've got 3 fifth root of x plus 1 cubed plus 1. That plus 1's outside the parentheses is equal to 25. Now, if we were to do this by hand, let's talk about it for a second. I would want to subtract 1, right? I would want to subtract 1. Subtract 1 from both sides. 3 fifth root x plus 1 cubed equals 24. Some of you already typed it in Desmos. Divide by 3. And if we were live, I'd be like, all right, y'all can go ahead and spit out the answer because I know you know it. Divide 24 by 3, that's 8. Alright, now, if I'm leaving this as a radical, that's fine. But here's the thing. At this point, it's just like, my goodness, Mr. Maston. Let's turn it back into rational. X plus 1 to the 3/5 equals 8. That would require me to do the following. 5/3. 5/3. So again, I'm just thinking strictly do this problem by hand. The cube root of 8 Alright, do the cube root first, it'd be easier. You don't want to raise 8 to the 5th power, that's nasty. Cube root of 8 is 2. 2 to the 5th power. That's 32. Subtract 1. X is 31. Now, if you want to go through and do the problem, you can. But let's check out Desmos to make sure. And again, you can check yourself with Desmos. You can do the problem with Desmos. So that's my recommendation. I know when I've taught this problem in the past, I've had students start on it. They're like, Mr. Maston, can we just use Desmos? I'm like, sure can. So we'll go over to miscellaneous. We got 5th root right there. We don't have to even change that part. X plus 1 in parentheses. Let's put parentheses in there. X plus 1. Drop my parentheses. Raise it to the 3rd power. Let's go outside the parentheses. Put. Make sure I'm outside. Plus 1. That plus 1 has to be on the outside. Y equals 25. Let's go to home screen and we can see what it looks like. You get a really cool graph. I dig this graph. Alright, but Y equals 25 is up pretty high. So we're going to go all the way up to 25. We see the red line. Let's just keep scrolling over. Forget it. X is 31. Now that line's not going to intersect that black line at any other point. So in this particular problem, we had that one solution. X equals 31. But I want you to realize, I went through that problem really fast doing it by hand. I've been doing this for a while. But that would have taken us a few minutes to do. At Desmos, gets your answers faster. And you've seen how to do it by hand. I know some of you want to do it by hand. Please do it by hand. But the rest of us, please use your technology. Get your answer using Desmos, or if you just want to check yourself doing Desmos. That is the last lesson of this unit. Hope this helps. And again, no Google Meets today. Guys, have a great day, and email me or message me your questions, and we'll work ourselves through it. Talk to you guys later.